Here we're going to talk about our congruent triangles, looking at one example. In this example, we're going to verify that two different triangles are congruent. We are going to look at the pre-image and the image. And what I would recommend, if it ever asks you to verify two triangles are congruent like this, and it gives you the coordinates of the vertices of the two different triangles, I would graph them. And that's what I've done here. I've gone into Sketchpad, and I've graphed the two triangles with those 6 different points. Now, think back to what it takes to prove that two triangles are congruent. You have to prove that we have 3 sets of corresponding angles that are congruent, and you have to prove that there are 3 sets of corresponding sides that are congruent. Well, to figure out that these two sides would be congruent, you need to figure out how long they are. The only way that I know how to do that on the coordinate grid would be to use the distance formula. So you'd have to use the distance formula. How far is it from -1,5 down to -4,3? Plug it in your distance formula to have it. Then you come over here and do the exact same thing with 1,5 and 4,3. What I've done is I've had Sketchpad take care of that for me. Not that I couldn't have done it with the side lengths, but there are all the side lengths of my image triangle Q prime, R prime, and S prime. Then I also have all the side lengths of triangle QRS. Now when I look at this, I notice that, yep, those two sides are equal in length, they're congruent. These two sides, are equal in length, therefore those sides are congruent. And these two sides are equal in length, therefore those sides are congruent. Which I'm going to come back here then, and being I have to verify that these two triangles are congruent, I want to state everything that I had over there. I'm going to say that segment QR is congruent to segment Q prime R prime. I'm going to say that segment RS is congruent to segment R prime S prime. And I'm going to say that segment QS is congruent to segment Q prime S prime. So I've taken care of the 3 sets of sides that need to be congruent. Now I need to look at the angles. The corresponding angles also have to be congruent. I'm going to hide the sides for the time being, and now I'm going to show the measures of the angles. Have all 3 angle measures there for triangle Q prime, R prime, S prime. Hide the sides for this one. Show all my angles. And when I look at this, I notice that angle Q prime and angle Q equal in measure, therefore they're congruent. Same thing's going to happen with angle R and R prime and angle S and S prime. Therefore, come back here, being asked to verify, well, I have to show that all the corresponding angles are congruent. I need to write this down. And my verification would be on the other one where I had the measures. Now for you, you would need to get a protractor to measure those angles. I don't want to write it like this. I want to have this one be the angle R, and this would be the angle R prime. So again, you need to get your protractors out, and you would have to measure the 6 angles and make sure that those measurements are equal for the corresponding ones. Now when I look at this, I have all my angles over here on the left side, I have all my sides over here on the right side. I've shown that I have those 6 pieces of congruent pieces. Therefore I know that these triangles are congruent. I have indeed verified that my 2 triangles are congruent. Now the last part of this problem is asking us what kind of congruence transformation is it. So I'm going to come back here and I'm going to look at these and hide everything to make it a little bit easier. And remember I have slide, so did it just slide left to right, up, down, maybe diagonally? Did I rotate it, or did I turn it, or did I flip it over some line? Well, when you look at this, if you look at where we started with the triangle here on the left, the red one, and to get here to the triangle on, the red one's on the right, to get to the triangle that's on the left, I flipped it over, and in this case it was flipped over the y-axis. Therefore, the answer to my question in the congruence transformation, this one is a flip, or sometimes referred to as a reflection. So there's the first one that I'm going to look at, example, and I will have more on another slide or another video.